now we want to do what it was doing. So we're still integrating this one. Let me scroll. We're still integrating this question. Number 2, we're still here. So I was saying that we can change this one to be root 3 u, because you know that root 3 u will give us 3u squared. So why am I doing this? I'm doing this so that I can try. I'm trying to have something like du over the square root of, if I'm having x squared minus a squared du, which identity, which trigonometric ratio will fit for this one? Is it arc sine or is it arc cos? Between the two?
Arc sine.
Arc sine. And if you are moving the x, so I wrote du, so the dx. That's what I'm trying to have. Let me just open. I'm still opening the guide on my other device. So meaning that, you know, that this one, we can write it as we can write it as what? The integral. It means we can change the 4/3, no? Because we must have that square. It means we're going to have the root of 4/3 all squared. I hope you guys agree with this. Minus, yeah, and then this one, it's fine the way it is squared. So now what I'm going to have, we're going to have a u. We're going to have what? 1 over the root of 4/3, the arc sine of what? Of root 3u over a, which will be the root of 4/3, and then plus c. Then if you simplify this, let me see what I'm getting. 4/3. Yeah, you'll get, and that one will be root of 4/3. This one will give us 3 root of 3/2, and then they will have the arc sine. And this one will give us root 3 divided by root of 4/3. It will give us 3/2 u plus c. So this is our answer. We'll just have to replace, where there is u, you replace with the value of u, it's x minus 1/3. It will be x minus 1/3 plus c. Then you simplify that, arc sine of 3/2x minus 3/6 plus c, which can be written as 3/2, the arc sine of 3/2x minus 1/2 plus c, root of 3/2/2. Then this will be, yeah, we can just leave it here. Yeah, I'm trying not to have, but it will be 3x minus 1. Yeah, it will be something like this. Yeah, can leave it there. So now let's go to trigonometric integration by partial fraction. No? Can I have another class? But yeah, I'll see them in China. Plus they don't attend. You guys, if you don't attend classes, I prioritize those that attend. You see it who you attend, so always when I'm free, I think about you guys. What is that thing? Let me just open your guide, no? So that we can do the first case, second case, case one. But today I want us to focus on that case whereby you have your degree of your numerator being greater than your degree of your denominator. Mm. So remember we've got 4 cases. Let me just write those cases here. But I've taught you guys this before. Case one, case number one. Let me do it like this. Case one, this will be case two, case three, case four. The first case is when we have got the denominator splits into linear factors. This one, you know, I'm sure by now you know how to separate the denominator into linear factors. And the second case, it's when now you have the degree, the degree of, and this is the one that I want us to start with, no? The degree of the numerator being greater than the degree of the denominator. So this is like it's when you have something like the integral of, now you find that here you have 4, let's say to exponent 5 plus 1 over x plus 1 dx. You see the degree of the numerator is greater than the denominator. But when you have the integral of x plus 1 over x 5 plus 1 dx, this is fine. Let's just use let's say you have this one. Let me change this one to be 2 so that I can show you. Let's say this one was 2. Yeah, if it's like this, you see the degree of the numerator is less than the denominator. You know that here you're going to just apply your partial fraction rule. Since this one cannot be factorized, we call it irreducible. So we're going to have a what? It was going to be I forgot the rule. Let me just confirm. Yeah, it was going to be ax plus b over x squared plus 1. And then you will multiply both sides by x squared plus 1 by x squared plus 1, right? And then you remain with this. And then you'll solve your a and your b. So this case is when whereby you have got maybe a linear factor or an irreducible factor. Irreducible meaning this factor cannot be factorized, but then the degree of the denominator is greater than that. But now when we interchange, now the degree of the numerator is greater than the degree of the denominator. You must use long division. So, okay, let me not remove this. Let me just write down here. So, example. We can do an example for case 2. But let me finish writing those other cases before. The third one, the third case is when you have what? Yeah, the denominator cannot be factorized. It's the one that I was talking about just now. The denominator irreducible. So this is there in your guide. You'll see them. They wrote 3.1, 3.6 quadratic factors. The denominator is irreducible quadratic factor, meaning that you have on your denominator, né, you find that you are having x cubed plus 1, or maybe this one can be factorized. Let me just write something which I put x5. Let's say you have x5 plus 1, or you have x2 plus 1. Yeah, we know that we can factorize both of these, né? So that's what we mean when we say irreducible. So we'll do an example of that. Then the last one is when you've got the repeating irreducible quadratic factor. So this one is when by your denominator, né, it cannot be factorized and it is repeating, meaning you have got a square there or you have got a cube. I am sure you understand by the way they repeat. Are you guys still following? These are the 4 cases that you must know. Now do examples. Is that fine? Hello. Let's say you have got this.
Yeah.
I was saying that now we can do examples. Né?
All right.
Yeah, let's say now you have got the second case, whereby the degree of your numerator is greater than the degree of your denominator, which is this one. You see, when you have something like this, they also give you a task that you can go and try. But this one, I'm just creating it by my own brain. So let's say you have got x to exponent 3 né, of x minus 1 dx. So this one is it's an activity. You will follow whatever I'll do here to try this one. When you are done, send it. So, yeah, send it on the group. Don't send it to me individually. I might know. I'll take time to respond if you do that. So when you have this, here you are forced to apply long division. So I'm going to do this. You put x squared minus 1, x5 plus 2. So I'm sure you still remember long division, right? And this will be x squared goes how many times into x to exponent 5 will be x cubed. Then x cubed multiplies x, we'll have x5 minus x cubed minus. Then this 2 will cancel, will remain with x cubed plus 2. You understand? Then now, you guys understand what I just wrote. You know that the 2 will
Yeah.
just come on. And then now you will see x squared goes how many times into x cubed? It goes how many times? Once. It will be x cubed divided by x squared. So you'll remain with x. So meaning here you're gonna have plus x. And then this x, you multiply it with everything there. You are gonna have x cubed minus x minus, then x cubed minus x cubed, then here you have positive x, and then you have plus 2. Ne? Yeah, you will remain with this. So you are done from there. You can't do anything from there. So this one is our what? Our remainder. This one is our answer. So you must change this. You must change this. This is in what? Let's just say it's in a fraction form. Ne? You must change it to, you must write it to its partial fraction form, which is what we'll write now. So the partial fraction form of this guy, x5 plus 2, x5 plus 2 over x squared minus 1, this will be equivalent to. So what you do, you take the answer and then you add it with the remainder over what? Over the denominator. So the denominator, the one that you were dividing this one into, it must come here. I think this is the only trick that you must do. That this one, it goes to the what? The denominator. That's what you must know, that it will come here. Let's say the dividend. Yeah? Let's just create our own English. Will be the denominator. So this is equal to that. You can prove it, né? For those are equal. You can prove it by just doing your simple maths. You write x minus 1 there. You know, this is over 1 over 1. This will be x cubed x squared minus 1 plus x squared minus 1 plus x plus 2. You simplify this, and just simplify it quick. Minus x plus 2. You see that we're going back way. We're going back there. This will cancel, and this will cancel. Then you are left with x5 plus 2 over x squared minus 1. Yeah, I think I've even managed to show you that those things are equal. So now, what does this mean? It means you're going to take this, you replace it here. You understand? You get it? And just say yes so that I know how to get plus 1 plus x. So I'm writing this where there is this one. Then we know we have plus x plus 2 over x squared minus 1. So I can just do this, the x. Guys, I was still on the same page. So finding the integral of this is even. The answer will be x4 over 4 plus x squared over 2 plus, then the only one that you must simplify is suppose is this one. So with this one, you're gonna apply, and I have another similar example. I sent you guys a document. There's a question there. You already have an answer. I was not supposed to send it. So here you'll say apply partial fraction again. In order to integrate this, because here you can't use substitution. So I'll just say from, then I take this one, I put it there, x squared minus 1 dx. So I'll simplify this one aside. So I can write this as x plus 1, x minus 1. Guys, I was still on the same page. And then we know if we are using partial fraction, these are what are linear factors. parameters. Ne? So we can separate, so we can say x plus 2 of x plus 1, x minus 1. This is equal to a over x plus 1 plus b over x minus 1. Do you guys know this, that these things are equal mathematically? Yes, and Sasha, are you guys following, or I'm just alone in this thing? Yeah. No, guys, you can't keep quiet. Let's talk. Are you understanding whatever I'm writing? Am I making sense?
Sangonya. Sangonya. Lo so tu se ke
Oh,
ta tse ina e bo recording.
so here we'll multiply both sides by what? Let me try to write clean things. Then x plus 2, I'm saying we can write it as its partial will be x plus 1. The second variable is b. Oh, and note, please note that here you can use any variable. You can put c and d, still fine, but you must solve for that c and d. So, oh, by the way, this is the rational. Yeah, let's call it. This is the rational fraction. Once I separate partial, it means separated. So this is our separated. So it's our partial fraction. So hence they are equal, these things, as long as you know the value of A and B. That's why on that one we had to apply long division. You see with this one, the degree of this one is what? It's less than the numerator. So long division doesn't have to be applied. So we'll multiply both sides by x plus 1, x minus 1, such that here it will cancel. And then I also multiply it here, x plus 1, x minus 1. And then here on the left, I'll remain with x plus 2. Then here I'll have a, then x plus 1 and x plus 1, I'll have x minus 1 plus b, x minus 1 and x minus 1, I'll remain with what? With x plus 1. So now I will have a, I can let from here, I don't like simplifying when I get here, I can let my x be equal to 1. You choose any numbers, usually numbers between 5 and 5, they will work for you to get the value of a and b. So if I put 1 on the left of 3, here I'll have 0 plus b2, then 2b3, then b will be 0 over 2. And in order to get, here just use common sense. I know that if I say let x is 1, a will be out. Now if I say let x be equal to negative 1, b will be out. So that's what we'll do. We'll say let x be equal to negative 1 now. Then you'll have 1 on the left. Then here you'll have a into negative 2 plus b into 0. Then our value of a will simply be negative 1 over 2. Then from there, you are just going to replace the value of a and the value of b. So we know a it's negative 1 over 2, x plus 1 plus b is 3 over 2 over x minus 1. Let me scroll, we'll come here. This, if you simplify this part, you will have what? You will have 1 over 2 into x plus 1 plus 3 over 2 into x minus 1. So now we know that, yeah, so this can be integrated. So we can go back and replace this part. So let's replace. We know that we're having the integral of x plus 2 of x squared minus 1 dx. So this is its partial fraction. This is the rational fraction. Then we'll have negative 1 over 2 x plus 1. By change 1 over 2 x plus 1. Then we'll just say the x plus 3 over 2 x minus 1 dx. We'll just distribute the integral sign here and also there. Ne? Then this will be equal to, I hope I'm not losing you guys. I will just take out the common factors, which will be negative 1 over 2 integral of 1 over x plus 1 dx, 3 over 2 integral of 1 over x minus 1 dx. So this will be negative 1 over 2. Since the degree here is 1, I will have the ln x plus 1 over 2 x minus 1. But if the degree here was greater than 1, you're not going to say ln. Ne? This only applies if and only if you are having the integral of 1 over x degree 1. This will be the ln of whatever is on the denominator. Yeah, now we have the answer. So I'll just write my answer. Let me just copy this. And paste it here. We're having that. So we know that our answer will just be what? 1 over 4x4 plus 1 over 2x2. So this is there on the guide as well. You can just go and confirm. And then now I replace this part with this answer. It will be negative 1 over 2 ln x plus 1 plus 3 over 2x minus 1. And then we open a new page. And then this can be simplified to. So remember that if I'm having ln, yeah, I forgot to write ln. It should be ln. If you have ln and ln, I can take out what? That's my common fact. 1 over 2. Oh, and by the way, this, remember that if you have got the ln, let's say you have a constant here, x, you know that this is equivalent to the ln of x to exponent a. This is a property. Ne? So because of that here, I can simplify and say I have the ln x plus 1, 1 over 2, plus the ln x minus 1 of what? 3 over 2. And this will be 1 over 4x4 plus 1 over 2x squared minus. Then if I have ln and I'm adding, right, I can simply do what? And this will be, okay, if I interchange this, let's interchange this, guys. can even interchange from here. You left the ln of x minus 1, 3 over 2, minus the ln of x plus 1, 1 over 2. I just want to apply the rules of log, nothing more. I'll have 1 over 4. And this one is positive. Swap x4 plus 1 over 2, x2 plus ln. Now I can do what? This is our A, this is our B. I will see x minus 1, x plus 1. I will divide. Then this one, it will be, you can say to exponent half, and then this one will have 3 there. Then it will be 1 over 4, x4 plus 1 over 2. This one I'm just simplifying, guys. There is no need to do whatever I'm doing, because we already have the answer. I'm just simplifying it so that it looks plus 1 plus 6. So this is the answer you'll find in your guide. Okay, and then we've got the case whereby the denominator, do you guys still have any as a repeating linear factor? Or we should stop here.
Push up.
Okay?
Network and so
Or we should stop here. But okay, you can just go and check it out. Now we have our denominator, having repeating linear factor. So let me give you guys 2 questions. Let me change it. I know you guys will like copy. Yeah. This will be, and I'll only change 7. I just changed the constants actually. But I can see if you guys are studying. And then let me now write. This one is when you have got what? Your denominator has got the repeating linear factors. And let me write the question whereby you have, let me check from those conditions. Repeating irreducible. This one, okay, this one is not. Yeah, for irreducible, is for irreducible. What? So let's say you are given integral. So I said by irreducible, we mean something cannot be factorized. Let's say you have this, then here you have that. You can go into that one. Yeah, let's stop here. I don't want to give you a lot of things. At least if you have got these 2, yeah, you have got case 4, and this one is case what? It's case for irreducible. It's case, no, for repeating. Case 4, and then that one is case 3. Oh, this one is case 3. And this one is case 4. Yeah, fine. We can log out if you are tired. So the next thing, wait before you log out. With, are you guys still here? Hello. Sasha and Tias, are you guys still here? None of you is supposed to be here. Logged out. Let me stop it. To learn.